Hi everyone. So this is the software called Cloudera. We'll have a quick intro about today's session about software installation. I believe some of you have done the software and some of you have not done. We'll share this the software link. You can do it on your machine. So we can start on to this. Okay. So mainly if you talk about Hadoop, Big Data, Spark, these are the softwares. Mainly the enterprise level companies like Cloudera, Hortonworks, Mapr are the major distributor taking the lion's share in IT industry. And yeah, this is what I'm using the Cloudera. We have a specific two tools in this. One is the Cloudera Manager, which is the monitoring tool. So on in this platform, everyone can work like a data development, developer, admin, uh, a person testing, machine learning guy. We have a Spark ML lib as well onto this. So let me just give a quick overview about the setup so you can work accordingly. So we can access through the terminal as well. We'll go one by one. Okay, it takes time to start. All right, so this is the terminal. Let me just okay, it will take time meanwhile. So let's before starting, I want to just understand what you understand with the big data. So Arun, if you talk about the big data, what exactly picture comes in your mind? I'm just putting on here, Arun. So let's have a quick interaction. Meanwhile, this setup will ready. Yep.
Right. So my understanding about big data is like, I mean, as the name implies, like huge volumes of data, right? So, I mean, like the traditional data warehouses, they basically have the usual way of storing the data is like from mostly in like row column wise data, right? So, and mostly like most of the data warehousing or ETL projects, what you see these days, like I mean, traditionally, like it has been used from different data sources, preferably like most likely like structured data sources, like and and uh, and we don't need much support for getting data from unstructured data sources into our data warehouses. So I believe like
All
Big
right.
Data is basically kind of a platform which basically allows us to integrate data from unstructured sources as well.
Mm-hmm.
And
All right.
this,
So I believe you have already this kind of project. So what the challenge you're facing in real-time project? Means the setup which you're using on your you're using Oracle database or some other platform. So do you think these platforms are good enough to handle the big data?
Uh, I believe, like, see, right now the kind of projects that I'm currently working on is like mostly, it's not like huge volumes in size,
Mm-hmm.
and I'm not sure like if even if big data is a viable solution for the kind of implementation that we are doing right now for one of my clients. I believe like especially when it comes to processing, storage, and things like that, even when you have humongous volumes of data coming in, then I believe like big data is going to be the ideal platform. And right now, the client that I'm working, they have never got into big data, but they are slowly venturing into Spark on the processing side, and especially on the data engineering tracks. So yeah, so this is what I have, or what I know about uh, the current working environment.
Okay, perfect. Thanks, uh, Kanan. So I believe the setup is ready. And yep, you can see here. You can see my screen. Hello.
Yeah, I see a login screen.
Okay, just kindly mute yourself. So this is the Username, password, Cloudera. Please, I will appreciate if you write down. We'll definitely will share the docs, the video, everything is with us. But I will appreciate if you write uh, your query to work with. That will help you to give you sort of like a revision. So the username password is Cloudera. I'm just logging. Okay. So these are the components which we are using in Hadoop ecosystem are there. And this tool is mainly used by the admin. Mainly if you're working with Oracle or some other different database or server that need to check the health of the cluster, either in Hadoop or any project, right? So if we talk about a third-party tool like Ganzilla and Nagios are the third-party tool which we implement with our project with server, and through which we can check the health of the cluster, how this all the components are running or not. But in Cloudera provide its own Cloudera manager. It's okay. So you see here, the health is green means health is good. Everything is for. If you're not using that, stop that. Why you're unnecessarily using your resource? You can do that. You see that if something goes wrong, it will become red. So something goes wrong, and see that. So the admin team, what it will do, it will go and check all this configuration. I'm just doing a short way. I will restart the machine, but in production, they just go and check all the uh, logs of this. Let me have it. What exactly this issue and how they start doing the troubleshooting of all these things. So this is the advanced way. That is the reason we are using the Cloudera Manager. It easily will handle uh, all the troubleshooting, all the if any components it's not working. The another tool we are using that is called Hue. It's being designed for the developer. Like we have a multiple ecosystem. When you're writing the query, we can use it from the terminal as well. Okay, this is what we are using the terminal as well. But yep, in production, we generally we're not using the terminal. We are using Hue. It's more interactive. You see that the setup is ready. Let me close this and see that health is good. If you check again, ah, a quick demo. Okay, you can see here. All right. So now talk about Hue. All the product of Cloudera, the default username password will be Cloudera. Remember, username password both Cloudera. So this is all what we have: Pig, Impala, Specials, File Jobs, Triple Scoop. You can you work with the whole workbench. Okay, there. So in MySQL, you can access run the query from the terminal or workbench as well. The same kind of uh, platform we have services that provide with the Cloudera. Okay. All right. So before starting, let's have just let me. Okay. So okay. So one of you have just talked about what exactly the IT industry, the problem we are facing. So Arun, which domain you're working on the project you have? It's in banking domain.
It's in banking actually.
Okay. So Arun, I'm giving you a quick scenario. I'm a client and you're handling my project. Generally, if you talk about in banking domain, we are having what do you say Oracle database, if I'm not wrong, right? So there, let me have it. So I'm giving you data, right? I'm giving you data, and through which you're handling my data there itself. Okay. So what I can do? I'm saying, hey, Arun, this is my data. So what you're doing, you're storing, you're making my data well organized, structured, and storing into the Oracle database in a table. And this is how you're getting the UI through which your staff are operating your data and giving the service to the customer. So what if I say, Arun, hey Arun, I believe the business is moving into online. Every business is moving into online. So even the banking is right now into online. So I'm looking to get my business into online platform. The reason is very simple and clear. The volume and value. This is the reason. Volume to value. You might be noticed that most of the app you're using, they are asking to share your data. If you're not sure, that you're not allowed to install that app. So what exactly the reason? Because they are getting the users data, and the backend they're doing too many analytics analysis of the data, and they are pitching to the customer as per the customer requirement. So we are looking the same, and the customer is also happy. We are saving the time and money for the customer. The customer is also happy, right? So it's a win-win situation. So we are also targeting the data. We are reaching, let's say we have a more than 2 lakh of customer. Okay. And every customer is using our app. So we are pulling the live data. It's 24/7. So means in a day we are targeting 10 plus GB of data. So what do you think, Arun? How are you going to help me? If I'm targeting a huge volume of data, means per day 10 plus GB of data. So how are you going to handle my data?
So what do you mean by like handle the data in the sense?
Like data storage, data processing, all this comes. Data extraction. This
Right.
is
So
what we do: real time, batch processing, all these things. What you're doing with that?
see currently the current project that we are working on, the current data warehouse system that we have in the bank, it is called as a central data warehouse or the enterprise data warehouse, what we are maintaining. So
Mm-hmm.
since you know that like bank as a bank, like they have data coming from different sources, like for different. So the current bank that I'm currently
Different
working,
sources, right?
yeah.
Right, right.
So our bank primarily operates for the loans and the loan origination systems. So we have myriad of sources, and majority of the sources that I've currently dealing with are from mainframe files. All right. So what they do is like they basically send us a mainframe file, and we basically have some sort of data ingestion process in place, which basically converts the mainframe, which is basically the XDD files into ASCII format files, and that whole transformation basically is basically happening through an automated Unix shell scripting procedures, right? So that is what's being handled. How it's
Perfect.
being handled on the ingestion side, the conversion of XDD to ASCII format. So as soon as like that is done, so what it basically does is like it basically comes into our EDW or CDW server, which is basically built on a Unix platform, and these files that we get it on different frequencies. We get it on daily, we get it on weekly, we get it on monthly, and at times we get some files on yearly basis too, right? So
What's the table size?
table size, the integration tables, the entire data warehouse size, or the tables, or the specific
A
tables.
single table, a single table. Let's say in Oracle, you're creating the database, and in that
Uh,
database, there are multiple tables. So what is the table size? In a one table, what the data you are storing?
so the primary tables that we have are loan tables and disbursement tables. All right. So the loan table is primarily considered to be as the biggest table that we have in our data warehouse environment, and which is basically an integration table. All right. So I believe we are maintaining close to almost 8 months of data in that
In
table.
GB or TB? What do you have?
What is that?
The table size in GB or TB?
It is in GB. It is not in TB.
Right. Okay,
It is in
that is
GB.
what.
Yeah, it is
Okay,
not in.
perfect. So
It is not in GB. It is in TP. So yeah, and we also have some purging mechanism on a monthly basis, which basically, or not on a monthly basis, on a daily basis as well. Once the load happens, like it basically purges a file, and it also basically dumps it into a different location. And once the data gets loaded, and this entire integration process happens to Informatica. Informatica is the data integration
Okay.
tool being
All
used.
right. Okay. So my why I asked this question that a very simple thing I'm asking. Back in too many tools, back in too many integration, uh, end-to-end solution we have. But a very simple question: if I'm having the 10 TB of data and where the storage is Oracle database, where you're holding in a table not more than GB. So this is what the production. Mainly the production, the table size they put into the GB, and the reason is very simple: scalability, the performance. Okay, they don't want to compromise. The table size in production max you can store, I guess it's 2 TB. Okay, but they prefer to go in the GB. It's very simple, because to maintain any tool, let's say your laptop having the 8 GB RAM, you won't run 8 GB RAM any software in a machine. It will start getting hanged. It will be slow. The performance will not up to the level. So generally we go half of this, 4 GB, 5 GB max with that. So the same reason we are maintaining the scalability by putting the data in a GB. But the client is expecting what, 10 plus GB of data every day. It is 5 times multiple what you have a table size. Even it's one day. So this is the one challenge. The volume is the one challenge. The second challenge is variety. RDM is purely designed for the structured data, 110%, schema based. Even a single schema mismatch, you will get an exception. And here 80% data is unstructured. Audio, video, images, logs, checks, everything we have. So how are you going to help me? That is another challenge. You can do the data filtration, data mining, but how long? Most of the data is unstructured and you're getting huge volume data every day. So that is another challenge. And the third and very important, data rate, the velocity of the data. Incoming data rate is very, very high. So let's say you are using a one app, okay, or velocity. What is velocity? Let's say you are having a cab service, Ola, Uber, you have a multiple cab, right? You have a services. So in cab service, let's say you're getting 22,000 clicks per second. We keep clicking, right? We keep clicking, we keep that technically it is what called click stream. It's not every time when you're opening the apps you are going to get the service. Sometimes it happen that you want to check all the services, what all the offers being there. So technically it is what called click stream, right? So based on this, they are getting 22,000 clicks per second. That's an example. 22,000 clicks per second we are getting, number of clicks by the users. Let's say 10% are users, 10% users are looking for cab booking out of 22,000. 10% want to book the cab. So means 22,000, how much? 2,200 per second you are getting the booking. Now you tell me how you're going to fulfill the customer demand. Within 5 seconds, if you not get that, if the customer do not get the driver details, they directly jump to the other service, Ola to Uber, Uber to someone else. So this is what the market expectation, this is the customer expectation. They don't have the patience to wait for a 5 to 10 seconds. So how are you going to convince them? So nothing to convince. You don't have a technical support, you don't have the customer care number of any of the cab you're using. You know very well what you have the other option. Rather than calling to the customer care, you can get the other cab in a minute. Okay, so this is the another challenge, how to maintain the velocity. So this 3V, technically what called the big data. This 3V is known as what? A big data. Okay, there are 7V, veracity or audio, video, images, but I guess that not required in IT industry, mainly into other geographical data they use this. So let's talk about today about 3V, volume, variety, and velocity, and how it's going to work. So the client is expecting the solution, because the current setup, you mentioned that COBOL mainframe. So mainframe, yeah, exactly, it's very outdated. Mainframe having the COBOL, if I'm not wrong, DB2 Okay, so the client is expecting fast solution. The client is expecting not the service. The client is not expecting the service. They need the fast service. This is what the market, right? And they start expecting, give me the big data solution, because this is not a normal data, because this data is not compatible. This database is not compatible. This infra is not compatible with this business model, with this technology, with this business model. So client is expecting, give me the big data solution where I can put 100 TB data and I can process the data in a couple of hours. This is what the expectation. So how are you going to help me? So you start working onto this. If you don't give the solution, you may lose the project. They start checking with other vendor. So the question is, from where they're generating this huge amount of data? Kumar, what do you think? Means 10 plus TB data is not a, it's not easy thing. So what do you think, from where they're getting 10 plus of TB data every day? Which platform, from where they're generating this huge amount of data? Yep. Kumar, you there? Uh, okay. Anyone?
Avi, can you please
Okay.
repeat the question once?
From where we are generating this huge amount of data? If I'm getting 10 plus of TB of data every day, so what do you think, from what are the sources? You mentioned the source, right? So what are the sources to generate this big data? What can be the source?
And source could be anything, right? I mean, it could be myriad of sources. Like it could be either from an API, or it could be from traditional databases, or it could be from any other third-party applications or ERP systems.
Okay. All right. Thank you. Guys, hope you all there. Can you write me, can you ping me in the chat window if you're there? I should know that, yes, you're listening me and you're following me as well. Okay, Kunal, thank you. Thanks, Priya. Okay, so let me show you something. ERP, logs, this all people are not familiar, but I believe what you can see on my screen, I believe many of you are familiar. Social media platform. Okay, so the social media in real time, this is what in real time. Okay, so this is one site, you can check that as well, which give some analytics of social media, number of clicks per second, per hour, per day, right? Get a fair idea. This is what all clicks we are having, we are getting every day. Interest working. So first we talk about the volume. Facebook generating 10 plus TB data hour-wise. The third, second is the variety. Social media, what we do simply, we simply drag and drop, in which it's audio, video, images, log, text, right? And the velocity, you can see that 1.7 million clicks per second. So social media in real time. Ultimately, these are nothing, it's all of the big data application, guys. Okay. So what all, most of the apps you're using, Ola, Uber, Facebook, Twitter, LinkedIn, um, your uh, let me show you. This is nothing, it's all of the big data application. So okay, so you can see one architect, the flow which we'll discuss. Okay, this is what Uber app. Okay, so what they do, they pull the live data from your mobile phone. When you download the app, they ask you to share data. So how they pull the live data from your mobile phone? They're using the Kafka. This is streaming tool. Okay, this is nothing. It's a streaming tool through which they pull the live data from your mobile phone. And Kafka is one of the biggest or one of the best tool you can say for the data streaming. And nowadays it is now coming with Spark uh, uh, as an ecosystem component. So through which they're pulling the live data from your mobile phone and they categorize the data, audio, video, and then storing the data onto Hadoop database. And then after the data gets stored, you can data processing. And this is Vertica. It's MPP tool. It's a license tool. We are not using a Vertica. We can replace it from your Spark, Python. You have means in Hadoop ecosystem we have Hive. Okay, and they generate one report, and this report we share with the team through which they can take some business decision what exactly they understand the customer nature as per the algo. That is being connected from data scientist as well. Okay, they need the data as well. The more data I have, then the more accurate result they can give it to you. So data scientists as well working on the same platform. Okay, so ultimately we come to know, okay, if you're working with the big data, then we have to find out some big data technology. So the the first technology what we have today is Hadoop. We have a Spark as well. So we'll go one by one. So Hadoop is a big data technology. So if you put 100 TB of data on Oracle, it takes couple of means day, it can take a month as well, no doubt. But if you put the same data on Hadoop and if you're doing data process, if you're doing the batch processing, it can process 100 TB data in an hour. So the reason we start migrating data from RDNs to Hadoop. That is the reason. This is how Hadoop comes in the picture. We get the big data solution, and we suggest the client yes, as per the expectation, as per this business model, this infra is not suitable. We have a technology that is called Hadoop, which is specially designed for the big data. So on the big data platform, you can migrate data from RDNs to Hadoop. You can use the how you can migrate data from RDNs to Hadoop. You have a Informatica ETL tool. So I guess Arun, you mentioned you're using the Informatica ETL tool. If you have this tool, uh, Informatica, I believe it's a licensed tool. If you have this tool, you can migrate this data from RDNs to Hadoop, and you can do that. But again, if you have the license tool, then of course in this training, if you say that Informatica won't possible. So what Hadoop comes with ecosystem? What Hadoop comes with ecosystem? So in Hadoop, we have one ETL tool that is called Scoop. It's open source. All the softwares which we're using, it's all are open source. Okay, and yeah, we can see here the Scoop we have, in which you see here. Okay, so using the Scoop, it's Hadoop ETL tool. Okay, through which we can migrate data from Oracle to Hadoop, and we can get the data. All right.
So, Abhi, one quick question here.
Yep.
So when you say that like you use Hadoop to actually migrate data from Oracle to Hadoop, right? So where does it land in Hadoop? I mean, are we going to put this on Hive or I
No,
mean,
no, no. We have a different label. We have a different label. So allow me some time. We'll go by one by one. I'm just giving the quick overview of this flow. Okay, in Hadoop we have SDFS, we have Hive, we have HBase. Okay, so we'll come. I guess other being there as well. So let me go follow the Means it will come in the next part. What we have Hadoop and components. In this, we will discuss about what are the different database. Okay, but finally, if you're using the Scoop, it can help you to migrate data from RDS to Hadoop and Hadoop to Oracle. It's vice versa. It's possible. Okay, it's possible to migrate data from one platform to another platform. All right.
Okay.
Okay. So once data comes on Hadoop, we have in Hadoop we have a two component. Okay. So if we talk about Hadoop, we have a database and we have a data processing tool both. Okay. We have a database and we have a data processing both. So if we talk about a database, the first the means you can say Hadoop component, like what we do have Oracle is the database where we store data, and we have SQL through which we process, we run the job. Okay, so we have a database that is called HDFS, Hadoop Distributed File System, and that is called MapReduce, which helps to process the data. Okay, so what exactly this HDFS and the MapReduce? We'll talk about this, but okay. So how? I'm just giving the quick overview and the project part how we work. So let's say the data. This is the two components. When you install Hadoop, these two components will be installed by default. Rest is what Hadoop ecosystem. Okay. So Hadoop component will come with Hadoop ecosystem. You have to integrate it manually, or if you're using Cloudera, it's all available. You can see this is all the component. SDFS, we have SDFS, we have a MapReduce. Okay, and rest are nothing. It's a ecosystem. So Scoop is also ecosystem. Okay, so that is what once data come onto Hadoop, they need to what they want to process the data, they want to store data, and they want to process data, and there they match the requirement. So the question come again. So this team start working onto this. Is it? No. They need to have fair understanding of Hadoop. So they have to develop the skills. So this is how the IT industry start learning Hadoop, and this is the reason you guys are looking for Hadoop today. So most of the project, if it is on Hadoop platform, and why? Because no such domain or no such industry are untouched from online business. Earlier it was a B2B, earlier it was a B2C, now it is a B2B as well. Okay, devices are, so they don't want to lose this. So yes, most of the companies are working with the big data. Not even the big data, they're working with now the fast data. And if they have the big data or fast data, then they need the big data technology. And you should know big data technology, and this is how you're learning. So this is all the team can learn it and they can work. And the best thing is it's not a specific tool, it's a complete framework. Hadoop is nothing, it's a framework. So this framework allow, if you're a developer, admin, testing, architect, means what are the profile you can work with that. In fact, you can integrate some of your technology with this tool and you can work with that as well. But yes, it is not recommended, mainly because the performance wise they recommend to use the Hadoop ecosystem, but you can use your tool as well. As I mentioned that you can use the Informatica as well. Okay, so this is how, and this is the story and the reason you are learning Hadoop. Okay, now what next? So if you talk about Hadoop, okay, any question guys? Can I get a quick response on the chat window? Yep. Okay, thanks, Kunal. All right, so if you talk about Hadoop, it's a framework which is written in Java, which have the two component, SDFS and the MapReduce. Being an admin, mainly you're into this, and being a developer, if you're into this part. So look, what exactly the MapReduce, how SDFS comes, what exactly meaning of SDFS, what is a MapReduce? Hadoop is not the first technology which is on big data. It's a Google. The world first big data application was introduced by Google in 2004, and that was nothing Google search engine. Later, in 2006, Hadoop comes in the picture, and write this as JFS from GFS, Google File System. Okay, derive SDFS from GFS, Google File System, and MapReduce is nothing. It's same. The algorithm used by Google. We are implementing the same here. We are using the same. So MapReduce work on key value. What is key value? Let's say you're looking for okay, you're looking for big data training, so you start googling, right, big data training, right? So whatever you write on the browser, whatever you write in the browser, it's called key. I told you MapReduce works on key value. So whatever you write on the browser, it's called key, right? What do you write on the browser? It's called key, and related to this key, what are the values? Means what are the result you're getting? It's called value. Okay, this is called value. So sorry, how many values we have? 2 crore 57 lakh. Wow, but we don't worry about this. We just get the result from top on the first page. On the first page, you have 10 organic result, and most are paid ads. These are the paid. These are the ads. These are the ads. Okay. The rest are coming on second, third. Many of you don't have idea means okay, is it second, third page as well. So we get the result from there itself. Okay, as per the Google result. So this algo, this when you write this key, actually it is being indexed like in Oracle. When you write the account number, right, we have the customer and it fetch the data of the account detail of the customer show on the screen. So it's the same way. It when you write this key means it's a you are asking that related to this key, what are the values you have, give it to me. So this is how index done by MapReduce, and it show the result. It retrieve all the data from the Google database. Okay, so SDFS and the MapReduce. But if you talk about the MapReduce, you should have fair understanding of Java. Okay, MapReduce is nothing new. It's a concept of Java. If any of you know the Java, it's a hash map. Hash map is based on key value. Okay, hash map is based on key value. That same concept you're using here, hash map. Okay, key value, it works in Java. But of course, if you're not from the Java background, then what you will do in that case? If you're not from the Java background, it's a big challenge, right? So is it mandatory that yes, I should know the Java, then only we can Hadoop? No. So that is the best thing about Hadoop. A person from IT industry, from the different skill, from the different uh, uh, profile, they all can work in Hadoop. So they start giving you option. So they come with a multiple ecosystem. So people not from the coding background, they are not from Java background, they can work with Pig. So it's a Hadoop ecosystem. So Pig is a what? It's a shell scripting, a basic understanding of SQL or scripting language. All right, can help you to learn with Pig. Okay, so let me do. Okay, let me. Okay, so what is a Pig? So I'll do one thing. We'll have a quick practical what we have discussed till now. Okay. So it will the POC, proof of concept, what we learn, what we work is coming here. It's a Linux interface, guys. Very important. You should know the Linux. Okay. So mainly in the Linux as well, we are using CentOS and Red Hat. Remember, no Ubuntu, no Mac. In production only we are working with CentOS or Red Hat. So you can see. Yeah, I don't know. It's not much used, but yes, being a part of this course outline, we are covering this all the topic. Most of the now in Hadoop platform, most of the tool has been replaced by the Spark ecosystem. So let me show the database first. This is what HDFS. Let me open this. So user Cloudera. This is what HDFS. This is the database where I have all my data available. Okay. So what I will do, I'm having one file, EVM electronic voting machine. This is a very good example, electronic voting machine. Hope you understand. Okay, electronic voting machine which count the vote much easier than the manual counting and give you the fast result as well. So we'll do the same today here. I'm having a one EVM machine. Sorry, EVM not machine. My mistake. I'm having a one EVM file in which I have some data of different political parties. Okay, so it's look like that people they just casted their vote to the different parties, and we have to count the votes. Okay, have to count the vote. So what we will do? So what I will do this job today. We'll count this vote today on this Hadoop platform. So I will store this data on Hadoop database first of all. This is on my local machine. I will store this data on a database, Hadoop database. And yes.
There seems to be a lag in the system actually. I mean, I'm getting the screen only after some time.
Okay. I guess everything is fine from my end. Other are facing the same. I don't might be it's internet issue. The speed reason you might be getting some delay while changing the screen. Other okay, fine. Arun, just check your network, please. Okay. Usually it happens when the network internet space is slow. So this is okay. I was saying that I will first store this data from local machine to SDFS and then process data, and then we'll count this using the MapReduce. Okay, we'll count it using the MapReduce, and then we'll count the same data using pig. So we'll show you the code size, the time taken. We'll see the statistic between the MapReduce and the pig and your comfort level. Okay. So Hadoop FS I'm using the Linux command. See here. Hadoop FS put home cloud desktop. I given the local path, and I'm saying that here store this data on my on SDFS. So let's say that SDFS which path I'm giving the path user cloud. This EVM file is already stored there, so I will rename the file name. Covaxin. I will name this file with the Covaxin. Now I will go and check this. So sorted by alphabetically sorted. So you see that the file is available now, and yeah, the file is ready. Okay. So right. So the first job is done, that SDFS. All right. So the data has been stored on my database SDFS. Okay. And next is what? Then we'll count this vote using MapReduce. Okay. So I'm having the jar file. MapReduce is nothing, it's a Java. So if any Java code you're implementing, you have to create the jar file. It's nothing, it's executable file. So I'm having cd user lib. You see this. It's all available in this machine, nothing to worry. Okay. So I will run this job, Hadoop jar. I'm using this jar file, guys. Hadoop example, this one, red one.
Hello, Avi.
Yeah.
I am only seeing your notepad. I don't know what's going on.
Other facing the same. Okay. What you can see now, is that my screen or a notepad?
I right now dialog box, a command prompt has come with Hadoop jar, Hadoop examples.
Okay, just one
Just now
sec.
it came actually. Yeah. I mean,
Okay.
like I mean, I did not see the initial the commands and all that you gave, right? I mean, how you started the terminal and all. My internet connection seems to be pretty good actually. I mean, there's no problem with that. I did a speed check.
Hello.
Yes, Avi.
Yeah, is it fine now? I'm typing.
I mean, are you doing something? I just see the command Hadoop jar, Hadoop hyphen examples. It's just stuck over there.
Okay. Arun, can you rejoin? Just disconnect and join it again.
Okay.
Yep. Other users are saying it's fine. Okay, let me check. Kunal, you there? Hello. Hello. Yeah, are you there? Kunal, you there? Can you come on here? Yeah, hello.
Yeah, hi.
Yes, please.
Yes, I can see
Is
your
it fine?
terminal. No, I can see your
Okay.
terminal. I'm not able to, like, if you're writing something, I'm not able to see that. It's
That's
written there. It's fine now. That's it.
okay. Now one sec. Just 1 minute in there. Can you see now what I'm writing?
No, it's
No,
stuck over there.
I'm not seeing as well.
Yeah, it's stuck over there on
Uh,
terminal.
okay. Do one thing. Just connect.
We can go on Google Meet,
I'm
I
sending you
guess.
one. Yeah, Google Meet. I sent it to you. Wait. Google Meet. Let me just. Okay. Okay. Just one second. Let me try it again, or else we'll send the link. That's fine. You can see my terminal.
Yeah, I can see your terminal, but it's all stuck there. Now you have just typed hi.
Yes. Yeah, I can see the same thing. Hi, hello.
Yeah, it's working now. Fine.
Yes,
Okay,
I can
okay.
see.
All
So
Yes.
right.
Avi,
Perfect.
yeah. So Avi, do you mind like if you just do a recap of all those things that you did because I could not see that like what
Okay.
you did.
Fine. Okay. Repeat this. Let me check the recording first. Okay, it's going to record. Thank you. So I told you that this is the EVM file. I'm going to store this file on my SDFS, which is on my local, which is on my SDFS, and then we'll count the vote using the MapReduce, and we'll count the same vote by using the pig, and we'll see the statistic for both. So this is the command I used to store this data on SDFS. Okay. Hadoop fs-put home Cloudera desktop and EVM. And this is the path in SDFS I've written. This file is already there in EVM, so I renamed the file name by giving the covaxin. Okay.
So Avi,
Covaxin.
how did you launch this terminal?
Okay, this.
Okay, system tools terminal. Okay,
Here as well it is coming on your machine. Or Control Alt T, the Linux short Control Alt T. Okay.
okay.
So Hadoop fs-put, and I can go and see this is the path. Sorry. So this is what covaxin file stored on SDFS. Okay. Told that the second will count the vote using the MapReduce. So this is the path where I have all the jar file available. User lib Hadoop. Okay.
No, what is this path, Avi?
Okay, this is the path, the jar file, MapReduce word count job. Okay, so I have to execute this MapReduce command to get the output, the count, right? So I'm using this jar file for
Okay.
this. So I guess Hadoop jar, jar file name Hadoop. Okay, then I will write the class name. The class name is word count of this job. So on which jar file you want to run this job? Uh, yeah, tell me please first. This jar you want to run on which file?
The file that you have moved,
Covaxin.
Covaxin, right?
Covaxin, which is stored on your SDFS. Can you tell me the path?
Slash user slash
So yes, let's use the cloud
Docker
data.
Yeah.
slash.
Okay. So is your cloud error. So you're saying that hey, run this job. Run this job. Run this job on this is my input file which is stored on SDFS. So this code will run on your SDFS. Okay. And it will give you the output. So you'll say, okay, so output will store where? Even output will store on your HDFS. If in SDFS, again you have to set the path. So you're saying that, hey, give me the output onto this path, cloud user Cloudera, and you have to create a one directory, Covax. Any logical name you can write. So this directory will create automatically, and it will give you the output. Again, you run this jar file onto this input file, and then it will give the output and on SDFS and this directory. This directory will create automatically. Let me run.
So I mean, this word count is what? What is that a program that has already
Class
been
name.
created?
It's a class name. Any Java having the class name. So I have written the same.
Okay. And the .jar file is something which is inbuilt, right? The Hadoop examples.
Right, right. When you get this set up in software, you will get it all. It's all inbuilt. All right.
Mm-hmm.
So see here. I'm just giving a quick demo. Don't worry for that. We have everything will go step by step, and we'll learn all this topic. And okay, I'm just giving the demo to understand this all pattern. So you see, and go and check the output. User Cloudera. See here, this directory created, and this is the output. The third file. Okay.
Okay.
Again, guys, this is I'm giving the quick demo to run the job to show you the output and everything. We have each and every component will go one by one. What is why we are running this command? Why the output 3 directory is being created? All right. We have not discussed this all the thing. What is the log? What is success rate? Okay. What is this jar file? Why we are using the jar file? We have not learned anything. We have not discussed anything. So I'm just giving a quick demo to make you understand these are the components, what we are using, why we are using this. A quick demo. Every topic we have a separate module, so we'll learn. Okay, so just have patience. Thank you. So guys, this is the output. Now you ask me how much time it takes to run this job. That's very important. So there's a one Hadoop job tracker. Now see, every job, whenever you run any job, a job ID will be created. Remember, let me show you this on the terminal as well. When you run this job ID actually created, so which you will find out the reference. So this is the job which hold all the information which you need. I told you how much time it takes. It's taken 37 seconds to run this job. Okay, and many and when the other info when we'll learn the MapReduce, we'll discuss about. Okay, all right. So this is all about MapReduce. What next? We talk about. So if I don't know Java, then I told you that we have Pig. So what we have in Pig? See here, I'll show you the code size of Pig. Very small, 3 line of data transformation. 3 line. So I'm giving that the path user cloud data. What is the file name we have? Covaxin, right? And I'll say this, and I will run the script file. So write simple Pig. And I will run this script file. Script file must be pig.pig extension. So exec. Let's execute this script file. I've given the path local.
So, the pig script that you just executed, is it not there in HDFS? It's there. It is saved in your local.
Yeah, code not on SDFS. You running this code on SDFS. Okay, you save this file on SDFS. The input file stored on SDFS. So you're saying this run, go to this node and run this code where the data gets stored. Okay. So see
Right.
here, the output is coming on your console itself, and you see that wherever in this a job ID has been created. See here, with Latin, and it's taken 34 seconds. Hope you get the idea. A quick demo about the MapReduce and Pig and how it works on that. All right. Any question?
Yeah, I mean, like I'm just trying to, trying to relate things from the projects that I've been working. And I mean, generic. I mean, not in terms of the functionality, but like, I mean, now you have showed like the pig script, right, which was basically saved in your desktop, and you basically had executed that
Mm-hmm.
the first command. But like
Mm-hmm.
most of the codes, like for example, like if you take an example of a Unix shell script, right? Just an example. Let's say like I create an Unix shell script to basically do some sort of formatting and to convert a particular file from one format to other format. So those like
Mm-hmm.
scripts is something that I don't create in a desktop or something. So I always have it placed in a server.
Of course. So you are having the Unix box,
Correct. Correct. So
right?
so in the case of pig, in the pig script that you have created, so that is something which is available in your desktop, and it is not available in your HDFS or your Hadoop environment. Correct.
Mm-hmm.
The script is not saved in your Hadoop environment. It is not
So
available in your
in
Hadoop
production,
environment.
mainly, of course, we are not using the local machine, right?
Right.
So the job will be the developer will develop the code, right? Then
Mm-hmm.
the testing phase will happen, right?
Yes.
Then if this all the testing phase then happen, this code will be deployed in the Unix box. From there, they will trigger this query. You got
Okay.
it?
Okay. Okay.
Okay. So this will have. So just give me some. We'll do this. So technically, it is what called Unix box, on which they do all this and work onto that. Okay.
Okay.
Guys, just give me 2 minutes. Just I'm getting a one call. Just be on it. Thank you. Yes, you're there. Hello. Yeah. Thank you. Sorry, it was called. So yeah, I was talking about, yeah. So generally we have a Unix box, and from there we write the script, and it triggered the job, and it give it output. All right. And of course, in production, you're not uh, storing the data from local machine, right? You're storing the data from SQL, right? So you're moving the data from where? From SQL, right? Oracle to SQL, and then you're processing the data, correct? So you migrate data from RDS to Hadoop as JFS. Here I will show you just local machine LFS. I show you, right? Here I show what? Yes, I move the data from LFS and store this data on SJFS. But just because right now I don't have a database. But in production, you are migrating data from DB to SJFS directly, right? Using ETL2. Then you will write the job and MapReduce and run this code onto MapReduce to SJFS. All right, Arun.
Yes,
Okay, thank you. Yeah, please write me in the chat as well. That's work well. Now, all right. So we'll talk about the SDFS architecture part. What exactly the SDFS, how it works, what are the component? Okay, what are the limitation? Let's see. I believe you guys are from the different domain using Oracle or DB2. Means mainly you're working with RDBMS. So what makes Hadoop faster than RDBMS? What are the limitation as well? And if there are such limitation, then what can be the alternative? These are all the questions we'll discuss. So mainly today we'll discuss about SDFS architecture, how this is being designed. So if you talk about Hadoop, it has a two version, 1.x and 2.x, right? Mainly in production we are using the 2.x. Even 3.x come, but it's still in testing phase. Okay, so what is the limitation 1.x and the limitation of 1.x? We have the solution 2.x. Okay, so if we talk about HD Hadoop, I told you that it has a two component SDFS, Hadoop distributed file system, and the second is what? MapReduce. Okay, but if we talk about in 2.x, MapReduce has been replaced from what? Yarn. Okay, there are certain things which has been replaced from the Yarn. If we talk about HDFS, we have three things: name node, data node, and secondary name node. These are the three components. Evidence short, you can write it on your notebook. It's a name node, data node, and secondary name node. It's HDFS. So this three node helps to store the data on SDFS. MapReduce, job tracker, and task tracker helps to process the data. In 2.x, we don't have MapReduce, we have Yarn. So who helps? What Yarn do? Resource manager and node manager of Yarn helps to work on that. So today's session we'll talk about SDFS architecture. Okay, this is the SDFS we'll talk about. So first we'll understand what is the role and responsibility, how exactly the name node, data node, and secondary name node work. Like you're in a team, so I will say Arun, this is the project. So what will be your roles and responsibility? First we'll understand, then how to start the work we'll discuss later. Okay, so if we talk about name node, let me do one thing. So if we talk about name node, right? Name node, data node, and the secondary name node, right? And SDFS component, this is the three things we have. So, Kumar, you are new into, let's say you get a job in Bangalore, and you don't have a permanent accommodation. So for some time you want to stay in a hotel. So you visit a hotel in Bangalore. So once you visit the hotel, you will contact with the first receptionist, right? You'll say, hey, um, I'm looking for a room. There are certain different rooms available, different type of rooms there. So you'll say, reception will ask the customer, okay, so what kind of room you're looking for? So the customer say, all right, I'm looking for this, okay, with this budget, something. So what is the job of a reception? Reception having first database. A reception will job is first to check the room availability. So reception is having a what? Is the customer. So reception will check its database, right? All right. And say yes, sir, room as per your requirement, the room is available. The room number 406. Room number 406 and the D Wings 4th floor is available. Customer said, okay, book the room. So what is the job that reception update its database? Okay, customer name is Sam. Sam is into this room, and let me just, why it is coming here. Okay, 406, and it is written there. So the customer stay in the room in the hotel. Okay, in this 406. One of his friend is called Sam. Say, hey, I'm staying into this hotel. Let's catch up. So the friend visited. The friends come to the hotel, but he could not reach to the Sam. So what is the job, friend? He again contacted the reception. Say, Mr. Sam, just checking in your hotel. Can you tell me the room number? The room details. So reception again check its database and say, yes, sir, this is what the room, you can go and make it. Why I'm telling you this all the process. We find some kind of coordination same in Hadoop when you are storing the data in SJFS. So what is name node here? Name node is a receptionist, a kind of reception. Data node is just like a room. Like in a hotel, we have multiple rooms. We have multiple number of data node in a cluster. Depends upon your requirement. What is this data size you can store? You can put that number of data node. Okay, so let's say Sam customer is having 1 TB of data. Just understand this. Sam is having 1 TB of data and want to store. So when Sam send the request, who will serve the request? Name node will serve the request. Why name node will serve the request? Because name node will decide where the data should be stored on which data node. Let's say you have a 10 different data nodes. Like in a hotel, we have a 10 different rooms. So which room should assign to which guest? Same way, so name node will decide. This is having some different algorithm. We'll discuss about that. So name node will decide on which data node data should store. So data node 1. Let's say name node decide data node 1. So SAM data gets stored on data node 1. That's it. Okay. Now, if Sam wants to read the data like this, so again Sam will send the request, I want to read the data. So again the request will be served by name node. Like the friend comes and friend want to know that this my friend is staying where. So again the reception will take the request. So again name node will serve the request, read or write any process. Name node will serve the request. So how name node will know? Like here the reception access this data from the database and come to know about Sam. So here the name node will also maintain a one database. Technically it is what called metadata, right guys? Metadata. That is called data of data, which hold all the information address of all the files available into this. It will read the SAM data. Let's say the SAM file name is what? FX. Okay, FX. So it's right. SAM data is stored on data node 1. Okay, so technically it is what called metadata, which is maintained by name node only. Okay, so name node will check. Okay, Sam send the request. Let me check whether SAM data stored data node 1. So Sam will get this access of this data node 1, and through which it will access the data. Okay, what in case if name node lost its metadata? For example, let's talk about Oyo. Oyo handling what? More than 10,000 hotels, right? In which state, in which city, in which hotel, in which room the case, this my guess is staying, right? You have the Oyo app and you do the same. So it has a huge database, right? Of a country, of a state, of a different city, right? It holds big database. And it's very important to maintain the database, and it's very important to maintain the backup of the database as well. In case if it lost this database, what will happen? It's a complete chaos. All right. So same way, if you say that name node hold maintain the database on metadata. In case if name node lost its metadata, who will give the backup? So this is the job of secondary name node to make the backup of metadata. Remember, name node will only give you the backup of, sorry, secondary name node will only give you the backup of metadata. It's not backup of name node, guys. It's backup of metadata. So in case if name node, secondary name node not working, sorry, if name node lost its metadata, you can ask secondary name node, hey, give me the backup. But in case if name node stop working, you cannot ask secondary name node, hey, give me the backup of name node. No, it won't work. Secondary name node is only the backup of metadata. That's it. Okay. So this is what name node is serve the request of, it serve the request, read and write, decide where the any user data should be stored, data node where the actual data gets stored. In a cluster we have multiple number of, we can put multiple number of data nodes. All right, let's say you have a one data node storage 1 TB, you have a storage of 20 TB, you can put 20 different data node. Even if size increase later, of course data is coming every day, so you can add a new data node in the cluster as well. What is the maximum data node? What is the maximum cluster size? 10,000 node. You can add up 10,000 node maximum, not more than that. That is what the maximum, that's the biggest size of the cluster, 10,000, not more than that. You're not allowed to do this. Okay, so it is called horizontal scaling. You keep adding the node in the cluster. It's called horizontal scaling. So you keep adding the data node in the cluster as per the requirement. Okay, so this is what metadata, this is what name node. Now the questions come here, if what name node down, what will do then? So this is what the limitation of 1.x. In 1.x we have only one name node, meaning if one name node down, there's no backup of name node, means it's a downtime. So admin has to check what is the issue. Till this node is not up, it will be not, it's a downtime. So it's a question, right? It's a big dependency of, and without name node you cannot do any job, right? Neither you read, write, you have metadata, all this thing. Second node having the metadata, but who will serve the request of the user? It's the name node. Second node cannot do this. So without name node you cannot think even to start the cluster. And that is the reason Hadoop 2.x come in the picture. It makes the backup of name node. It's called active and passive name node, meaning there's a backup of name node that is called passive name node. Means active name node, if it down, the passive will become active. There's no downtime. So we'll learn this in yarn. Okay. So I guess we have 5 minutes more. Let's have a quick query. If you have any query, please write me in the chat window, or you can come on here and ask your question. So we'll continue with the next session. Yarun, Kunal, Priya.
What is that? Avi, come again?
Yeah. So this is done for today. If you have any question or query, you can write me or you can ask me.
Right. And about the software setup, right? So are you going to
I
give us
will
an?
I will ask my team to send you the software link by today only.
Okay.
Download. What you're using, which Windows or Mac?
Windows.
Okay, you get it. You have VMware Workstation something?
No, I don't. No, but it
All
was
right.
agreed, right? It was. I mean, you said like it's going to be in cloud, right?
We have this setup cloud. It's little early to jump onto cloud. We'll give you that setup. Don't worry. Let's do it on your machine. Learn it first, then we'll go to the cloud at once. Okay.
Yeah, but yeah, well, what's the minimum system requirement?
I will ask my team to send you all the details. Just allow me some time for that. Okay.
Okay.
All right. So just I will share the link. Wait, just be online. I guess Kumar, you have done your setup run, right? It's all good. Yeah, any question, guys? Please write me in the chat window. Okay, thanks, Kunal. Yeah, I think. Yeah. I don't know. Did you get that? I think link I have shared.
No, I did not. Yeah. Okay. HTTPS.
So there are softwares. VMware Cloudera Quick Start is there. You just get it done. And VMware Work. Which operating system you have? VM Workstation. It's a Windows 10.
Yeah, Windows, correct.
Okay, I'll send you the link for the VM Workstation. You do it from there itself. Cloudera Quick Start. You have to download the Cloudera Quick Start from this. Okay.
So I see many options here. So download the image of
Yeah,
Cloud Quick Start, right?
You can see my screen.
Yeah, yeah. Cloudera
Yeah.
Quick Start. Okay.
Download this. Okay.
Okay.
Rest software setup will say.
Is there any minimum requirement for this, Avi?
4 GB RAM minimum.
4 GB RAM, right? Okay.
So this is how you have to stop. You have to not directly stop. You have when you're closing this option you will get it in Mac. I have default set by default. Power off, or there's a called there's one more option. Always select the power off. Okay.
Okay. So once I download the software, like how about the installation? Do you have any documents for that?
I will send it to you. Okay.
Okay.
I'll send you that. Get the software ready. That's it. It's a Cloudera Quick Start. Once it downloaded, you have to just unzip that. Nothing else. All right.
Okay.
And VM Workstation, you have to just download and just install it. Key and everything, we will do it before the session. All right.
So yeah, so there are two things, right? One is VMware and the other one is the Cloudera Quick Start, correct?
Right. Right.
Okay. And the VMware, where do I download the VMware from?
I will, as I said, I will share the link to you.
Oh, okay.
You'll get a. Okay.
Okay.
So get the software just download it.